Hello everyone. So welcome to the first lab of advanced topic in cloud computing. I am TA in this course. My name is Purvesh Rathod, and yeah, so we'll be doing the first tutorial on introduction to Docker. So in this tutorial, we are going to discuss about basics of Docker and how was the deployment techniques before Docker was introduced, and some hands-on on Docker. Let me know if I'm not audible. So let's talk about the days before Docker was introduced and how deployments were done at those times. So before Docker age, the DevOps engineers or let's say system admin, if so consider you want to deploy an application on server and you are like using microservice for example, and there are n number of languages are there, and for example as you can see here, the server requires Python 2.4 and Python 2.2. So it is obvious that you will need two servers because you can't install both at the same time and like other languages do. So in those times the admin will have to configure the servers manually. They will have to install the languages or the required libraries, and then they will have to deploy the code from one environment to another, and that was a tedious job, to be honest. So next comes virtual machines. So now consider that you have a server and you create virtual machines out of those server. So you can use the same server and make virtual machines for each of your applications. Let's say one application uses Python, another uses PHP, and you'll be able to manage those using VMs. But so for example here, using Chef and Puppet, you can like it helps to manage those large number of VMs. But if you have hundreds of VMs, then it will be really hard to manage all those, right? So this was also like issue. So here comes Docker. So first of all, what is Docker? So Docker is an open platform that enables developer to build, run, deploy, and update and manage containers. So basically, from the logo, you can see there's a ship and the containers. So similar in that way, what Docker does, it ships the containers. So what are containers? So container is a standard unit of software that packages application source code, executable components, and OS libraries and dependencies. So basically, when you create a container, it will like package all your source code and the libraries which are required to run the container. So this is what container is. And know that Docker was not the inventor of containers, but it just made them easier to use. So like how container works. So the technology behind those is like Docker uses Linux kernel feature called namespace and C groups. So what namespaces is basically is namespaces help processes to like isolate themselves. So for example, when a process is running, other process won't be able to access the resources which are there in the one process. So it will be able to isolate them. And the another one is C groups. So C groups are control groups which helps to limit the resources. So using C groups you can limit your memory or disk. So using those two things, the technology behind the container was possible. Now you can see that containers are basically just like VMs, right? But they are not. But so like just like VM, container will have its own IP address, file system, their own process space, and the major difference is like to run a VM you will need an OS, but to run a container you don't because Docker does it. So when you run an application using container, it will just have the things which it needs and it will run. So because of that, containers are very lightweight and small. And one more pros is like if you set up a VM, it will take a lot of time to set it up, configure it, but container just runs. So more about containers. So here containers are like secure because they are immutable, and if you modify a container, then it will become just another container. So by default in the container everything is off, so all the ports are off in the container that we will see in demo. And just like I said, like control groups, so in the container we can limit the memory and file system. So containers are lightweight. Containers store only the things which it needs to run the software, nothing else. So they are really lightweight, and elimination of configuration errors. So once a container runs, it will run everywhere same. So you might have faced this issue like it works on my machine, but it won't work the same in the different machine. So this issue is fixed by this. So if something is working in your machine or container, it will be working the same in the different environment. So there are two important things in Docker: image and containers. So what are images and what are the difference between them? So image is the application which we want to run, and it is a read-only template which tells like how to build a container or how it will be realized. So here in the photo you can see there is a Docker file, and it is using Node Alpine, and these are the steps which will be used to create a container, and this is how the container will be created. So basically it is a template for a container, and you can run many instances of a container from a single image. So image can exist like Docker image template can exist in isolation, but container can't exist without images. Here let's recap the infrastructure shift. So in 90s there were mainframes. So there are giant like PCs which were used for the computation. So it then shifted to PC, which are like distributed, and then from PC we went to bare metals. So bare metals are basically server, and on that you will run your resources, and on the top of that it was moved to virtual. So you will learn about virtualization in the lecture. So basically on the bare metal you will install a hypervisor, and that will virtualize your machine, and then you can create many numbers of virtual machines. But then there was an issue of maintaining the servers and VMs. So later it got shifted to data centers. So a company can like have a big data center to manage those infrastructure, but then again you will have to manage the data centers, and to manage your data center is really hard because you have to like consider security and patching and all. So why not give it to someone else? So that's where cloud comes. So here cloud manages your cloud manages the infrastructure. You just rent the resource from the cloud and make your application and focus on your business logic. So currently, as you can see, host to containers. So this is where the Docker comes. So even in the cloud now we use container to deploy our applications, and cloud providers like AWS provides platforms such as ECS and ECR, Elastic Container Registry and Elastic Container Services, and same in the Google. And later in the lecture you will learn about the Kubernetes, which also uses containers to run those applications. So there's the shift, and here at the end you see serverless. So how many of you know serverless? Yeah. So the name says serverless, so you don't need any server. You just, so for example, AWS has a service called AWS Lambda. So you just write your code and it will handle your servers. So it is the future, I guess. So it's like you just select a language and it will just manage the infrastructure and everything. It can scale up, scale down, everything. You just need to write the code and create the serverless function. So yeah, after you learn it in the lecture, it will be really useful. Yeah.
Why do we not talk about Fargate as a solution when we talk about serverless?
It is also like a service. So yeah, so Fargate is also a serverless service provided by AWS. But so it comes under the platform as a service, and when we talk about Lambda, it comes under the function as a service. So they are both serverless technologies. It just comes in different like platforms. I think I'm going too fast. Yeah. So getting started with Docker. So here you can see Docker Hub. So basically it is like repositories for images. So just like GitHub where you store your code repos, on Docker Hub you store your images, and you can use other services also. Like in AWS there is ECR, and in GCP there is Artifact Registry, which also does the same thing. So they are the alternates to this. So here, as you can see in the Docker repository, these are the top images, and here in my repository I have pushed those two images. So you can, if you create an image and push it to your repo, it will be under the repositories, and if you want to search any image, you can go under this. For example, in Python, if you want to use this image, you can use this one, but I would suggest you to use Slimbuster or Alpine, because they are like very small image compared to the original one, as less things are packed under it. So yeah, and if you want to get started with Docker and do some hands-on, you can refer this website. It has really good tutorial. I'll add. I have added this link in the PPT, so you can use that. And the third one is play with Docker. So to use this, you'll have to first create an account on Docker, and after that, you'll be able to use it. So it is free and it is sponsored by Docker. So you can just create an instance and start doing your work. So it has already a Docker pre-installed in it. So it is just like a machine on the cloud which is running, and with Docker pre-installed. So if you don't want to use your machine to play around it, you can use this one. This is really helpful because time by time you will need to delete the images which you have pulled or created, because it will take some space from your machine. So Docker hands-on. I have installed Docker in my machine. So if you are using so from this page you can install Docker for any OS. Previously, when you install Docker in Windows, there was a hassle because of WSL2 and all, but now I think it is really smooth and it is pretty easy to install Docker. For all those who are using Linux, if you install Docker on Linux, it will be installed under sudo user, so you have to manually create a group to make it accessible by normal users. So just a note on that. So now I'll do some hands-on on Docker. So when you type Docker, it will give you the list of commands which can be used. So and it has like pretty good description too. So you can refer those. And currently my version is 23.05. So I'm going to pull an image. So if you know about Nginx, it is a like web server. So I have pulled it and it has installed everything and it is running. So here I'll just explain the command first. So docker run -p. -p is for publish and 8080 is the port. So let me explain this in detail because it is really important. Okay, so yeah. So here this net is your Ethernet, let's say, and this is your firewall which blocks all the incoming data. So in Docker there is a virtual network, and by default there is one network called bridge or Docker 0. So now I have created one container. So let's say it is Nginx, and as you know I have written like -p 8080. So here what -p 8080 is, so it is short form of publish, so you can write -publish and then write 8080, or you can write -p 8080. So here it says that from the TCP IP of my machine, port 80, connect to the port which is running under the container, and that port is 80. So the container, so the Nginx image, so the container is running on the port 80, and whatever traffic comes on my machine on port 80, it will be redirected to the port under the container on the port 80. So to simplify this, let's say this container is running on 80, and as I said, like by default network is bridge. So if you're just running an image, it will be under the bridge. We'll talk about networking later. As of now, just know that there is a container which is running on port 80. Now if I don't connect this port to my machine port, then it won't be able to redirect the request coming from my machine to that container. So here what we do is, so here this is the 80 port on my machine. So this is what it does. So it just connects the TCP port of my machine to the container, and then it will be able to communicate it. So let's see if it is working. So as you can see, it is running. So this is how it works. And for example, if I create a new network, and let's say I have a container which is running MySQL, and one more container which is running Python. So it is a Python app. Now, since both of these containers are present in this network, they'll be able to communicate directly without any things needed. And let's say I'm running this on port 5000. So I want to redirect traffic coming on my machine from port 5001 to this Python application port 5000. So if I map that 5001 port to 5000, then it will redirect all the requests coming from let's say localhost 5001. Then it will send the request to the container inside port 5000. So you should like really know the difference here. And same in this. So if you write publish 8080, so this is your machine and this is the container. So as you can see right now, if I stop this, the container will stop running. So how do I keep it running on the behind the scene? So if I add a flag here called detach, or in short -d. So it is now running in the background and my console is free now. So if I write docker ps, then it will list out all the running containers. And if I write docker images, so I have one docker image. And if you want to stop a container, you can just use a shorthand. So you don't have to write whole container ID. If you write just the three things, then it will just stop the container. So if I write docker ps again, it will be like removed. And you can also use docker desktop, which helps to visualize things. So so far, does anyone have any question?
What do you mean by publish?
Yeah, so publish is like just a keyword which is used to, like, it is defined by Docker, so that's why it's called published. So it means like you're mapping two ports, one from your machine, like one from your machine Ethernet ports, and one to the container. So that's like.
When you say that there are two ports in picture, right? Do you mean they are actually like you're sending the data from one to?
Yes, that's what it's like happening in the behind.
In a given example, you have mentioned both the ports at 80. So what is the need? Because although we are mapping it to 80 itself, so and equal is also 80, right?
So Nginx server by default runs on 80 port, right? But it is running under the container.
Okay.
But you need to access the container from your machine. So to access that, like from the browser, if I write localhost port 80, if I don't publish it, it won't be able to access from my machine. It is just inside the container right now. So here, this arrow you can see, this is not there. So once you write -p 8080, it will create a bridge between them, and that's how they can communicate with each other.
In case that we are just simulating an environment to run our microservice application, so do we create these bridges, or we create a network and run all the containers in that same network?
Okay, so it depends on how you create those microservices. So you can use Docker Compose, which will be like coming in the later tutorial, or you can use like manual. So for this, you will have to create a network, and you will have to attach the network to those containers, and that's how they will be able to interact with each other. But if you use Docker Compose, it's like by default. So if you use Docker Compose, you won't need to create a network. It will be like created by like the Docker. So a tip for you for the assignment is Docker Compose will do that for you. We'll go to the assignment at the end of the lab. Any other question? So like I said, we have ran Nginx server, and using this command, it will be running on your machine. If you want to get the list of images, you can write docker images. Docker ps shows the running containers, and if you want to check logs of the container, so you write logs. This command will be like handy if you are creating some application and you need to see the logs. of the application. So another one which is like really useful is exec. So let's say I'm running this nginx container, and it is based on like Linux container. So if a container has its own file system and networking and all, so if you want to access or check the file system inside a container, then you can use docker exec -it -i is interactive, and t is to load a terminal in the console, and I have written container ID, and bash is to open a bash script. So now I'm inside the container. Now if I write ls, this is the file structure inside the container. So again, a pro tip for your assignment, you can use this command to see if the file is mounted in your container or not. And another one is docker container stats. So from this command, you will be able to see how many like memory your container is consuming. So if you have n number of containers, then this command will be useful. So before going to questions, let's do a demo on Python code. So we are going to Dockerize a Python application, and for example, I have created one small Python application using Flask. So here it creates a server and creates an endpoint, and once I run this, it will host the website. So let's just run it. So as you can see, this is running on my machine if I manually run it. So we are going to do it using Docker. So we are going to Dockerize this application. So first of all, we are going to create a file. So to Dockerize an application, you will have to use you have to create one Docker file. So let's just go through each step here. So the first line from Python 3.8 Slimbuster. So I'm pulling out an image from Docker Hub, and it is Python 3.8 Slimbuster. So I'm using Slimbuster because it is like really small in size. So that is why. And Docker images are built from layers. So each command or two commands are a single layer in the Docker image. So the next line is working directory /app. So I'm telling that I want to set the current working directory as /app. Now the second thing which I'm doing is copy requirement.txt. So this is like my source, and this is destination. So it will copy this requirement.txt in this folder in the container, and when I say run pip 3 install -r requirement.txt, so it will install all the libraries which are present in this to the container, and then I'm writing copy dot dot. So copy from destination to source. So what it does is like it will copy everything which is present in this folder to the container, and at the end I'm writing inside the cmd I'm writing python 3 -m flask run python. So this is like the command to run the Flask app. So does anyone know the difference between run and cmd?
CMD is like the entry point.
And run? And what about run?
Run selects place you to go next. It's a build step.
Yeah.
The entry point inside your Docker lifecycle.
Yeah, that's correct. So run is a build step, and cmd is the entry point. So this is always going to be executed at the end, and run is like when you create an image. If I want to add another command, then I will just write run and then command again here. So it will just run that command. So let's containerize it. So this is the app, and this is the Docker file. So to build an image, so the command is docker build -t is for tag. So I'll write sample app, and dot is like to create on this path. So when you should like give the path to the Docker file here. So currently I'm in lab folder, and the Docker file is in the same folder. That's why I'm writing dot. Otherwise, if Docker file will be somewhere else, then you'll have to specify the path of the Docker file. So it is building. So as you can see, it has like built the image, and these are the layers of the Docker. So let's just check if it is created. Now we'll run the image. So I'm running the app to, so if you know Flask, if you don't mention any port, it will run by default on 5000 port. But if you mention a port, it will run on a different port. So right now I have not mentioned any port, so it will be by default running on the port 5000. So docker container run -p is to map the ports. 5000 is my machine's port to the container's port, which is 5000. I can write a name. Python web server and name of the image. So it is running on the console, but I want to run it behind the scenes. So I'll write -d. I'll just rename it. So here, as you can see, this container is running. The name is Python server 1, and here you can see the ports are mapped from my local machine 5000 to 5000. And if I open this again, so it is running here. Now we'll go inside the container, just like we did for Nginx. So docker exec-it container id and bash. You can use sh or bash, anything you want. So here, as you can see, I'm in the /app directory. If I say ls, so inside the container we are under the app directory, and these are the files which are currently there in the container, or which are copied from my system to the container during the building part. And if I go to the home directory, then as you can see, this is the file structure of the container. So you can reuse this command for your assignment, and that's how you will have to build your application. So any doubts in this?